In class, we got the predicting reaction question, okay, for the last year's test, 2011. And I'd like to do is to kind of go over the answers, but also to look at some student answers that were released by the College Board and kind of grade them in front of you, give a chance to see where people make little mistakes, where their points come, and where they lose some points. So be sure you try this before you actually go through this tutorial. Now, looking at the questions here, you probably don't have time to do all this reading, but things you should watch is you're going to have to write a balanced equation for the reaction. Okay, be sure that when you do it, you turn to the lowest whole numbers, so no fractions. So if you do a reaction where you get a half or something, then be sure and go back and double everything. Everything's aqueous, just go ahead and go with that. And if it says something is ions, okay, then be sure and write it as ions. In other words, break up anything that is very soluble in water if it's a solution, or a strong acid should be broken up. And it says omit formulas for molecules that are unchanged. In other words, get rid of any spectator ions. So what you want to do is you want to write a balanced net ionic equation. And it also mentions that whatever you write is going to go into this box right here. So some people I've seen, try to do all their work. They do the molecular and ionic and net ionic equation all in that box, and that's really, really hard to grade. So the idea is that there is room down here. So go ahead and do all your scratch work here, and then go back and write your balanced net ionic equation. Okay, the last part here is that this is worth 10% of the second part of the test. So it's not a heck of a lot of points. It's 5% of your grade overall. So you should go in here and maybe give yourself 10 minutes, on the second part of the test. This is question 4. Give yourself 10 minutes for this to get as many points as you can, and then move on. You can always come back to this if you have more time. Now let's try the first question here. Solid magnesium hydroxide. So if we know our ions, we know that that's Mg, OH taken twice, and as added to a solution of hydrobromic acid, so that's HBr, and we should realize that that is a strong acid, and we're going to break that up into separate ions. Okay, magnesium hydroxide, hydroxides are not usually soluble, but the fact that this is a solid, we shouldn't even bother about whether this is soluble or not. So the equation then would be magnesium hydroxide plus HBr, so H plus and Br minus. Okay, the H's and the OH's are going to turn into waters. So we're going to see we're going to have 2 of these waters. And what do we have left over? We have magnesium and we have bromide. And magnesium bromide is not a precipitate. So we're just going to make the waters. And we can kind of see that that hydrogen there, that's going to be a spectator ion. So now let's make sure everything's balanced. Okay, oops, that was wrong. We want the hydrogens, we don't want the bromide. The bromide is a spectator ion. So we're going to have magnesium hydroxide plus 2 hydrogen ions turn into 2 waters like that. So here it is. Now notice we do not need to write in our little solids, liquids, don't need the phases, just whether it's together or apart. So as it's written, that would give us full credit. The bottom part is saying what volume do you need to neutralize your magnesium hydroxide. We've got 0.1 moles of magnesium hydroxide, but what that means is we really have 0.2 moles of hydroxide. Now, the hydroxide is going to equal the H+, so we really have 0.2 moles of H+, if we want to try to neutralize that. And we know that the volume times the molarity gives us moles. So we want to know what volume times 2 molar will give us 0.2 moles. And that seems like it should be obvious that that volume is equal to 0.1 liters, okay, which is 100 milliliters. And because the answer says here, what volume in milliliters is this? So we're going to show 100 milliliters is our answer, and that's worth a point. So watch out for the fact that they are asking for milliliters, so we don't want to give that answer in liters. Okay, our second one, excess hydrochloric acid. So we know hydrochloric acid is strong acid, HCl, is added to cobalt 2 nitrate. Okay, so cobalt 2 nitrate. So what is that? Cobalt is 2 plus, and nitrate NO3 1 minus. And this is a solution, and nitrate compounds are always soluble, so we're going to be sure and write those as separate ions. So the first kind of thing, gut reaction one might be to say, well, let's do double replacement, H with the nitrates, okay, and CO with the Cl2s, or the Cl minuses. But that doesn't really do us a reaction. Plus, they tell right here it's a coordination complex. So that means we've got the positive ion in the center, and then we're going to put 4 ligands, because it's 2 plus, we'll put 4 ligands. And what are those ligands? The ligands are the chlorides. So the actual reaction is going to be cobalt 2 plus 4 chlorides turn into COCl4, and it's 1, 2, 3, 4 minus and 2 plus. So we have minus, 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 and minus, and 2 plus. So this whole thing is going to be 2 minus. So that's going to be our reaction. Which species is a Lewis base? Okay, when we come into this complex ion or coordination compound, then it's the lone pair on the chloride that is going to cause this to be stick to that positive ion. So it's a Lewis base, where say the chloride here is, has a pair, it's going to share. So have pair will share Lewis base. So the Cl minus is a Lewis base, and that's all we have to say. Okay, last one here is a copper wire. So copper wire is just a piece of copper mixed into a solution of silver nitrate. So we know silver nitrate, that's going to be soluble because all nitrates are soluble. So we pretty much guess already that that nitrate is going to be a spectator. So we're going to be with silver. Now if we have a metal, it's going to have to turn into an ion. And I always have a situation, if this could go copper 1 plus or copper 2 plus, I go all the way to copper 2 plus. Now that copper went up, so the silver is going to have to come down. So come down to neutral, and we can see that we're going to need 2 of these, because now I have 2 pluses on both sides. This is my reaction. Copper plus silver ions turn into copper ions plus silver. Describe what is observed. Okay, now we did this in class, where we had for our copper Christmas tree, and in our Christmas tree then we had a piece of copper metal, and we saw that we got all kinds of little crystals on here. And I don't know if you noticed that if you let it sit long enough, the solution itself got kind of blue, and the copper wire gets to be less and less, but you really don't notice that unless you leave it for a long time. So say what is observed. So we say, okay, that silver metal is formed. Okay, that would be nice. You can also go back and say, the solution turns blue. And you could also say that the copper metal disappears. Okay, all 3 of those things would be good, but the most obvious one is that some silver metal is formed. Now what I'd like to do is to go back and kind of grade some other people's answers. Okay, so these are from students, across the nation, who on the back of their paper, you can check off that, yeah, it's okay for you to use my answers if you want to, and then no names are involved at all. And I have 3 different examples. Somebody did really well, somebody did medium, somebody did not so well. Okay, so let's look at this one. So solid magnesium hydroxide, so they've got that. And they've got hydrochloric acid, they've gotten rid of the chloride, so they're doing great. And we can see that they've got the hydrogen in the hydroxide turns into water. Okay, and they've got the magnesium, and this shows me that I messed up my answer way back in the front. I left off my magnesium ions. So on my answer way back in the early part of this tutorial, I would have lost a point right there because I'd forgotten my magnesium. But this person didn't. Okay, magnesium, magnesium. Okay, and you can also see that, that he's got 2 pluses on the left, 2 pluses on the right, so everything here is balanced. Okay, this person would have gotten full credit. So they get 1 point for the reactants. Okay, they would have gotten 2 points for their 2 products, and everything is balanced, so that's 4 points right there. Let's look at this person. Okay, solid magnesium hydroxide, HBr. Okay, that's a strong acid, so they should have split that up. So they just lost their reactant point. Okay, now in the products, okay, magnesium bromide, okay, that should have been split up, so they just lost one of their product points. But they did get water, so they got one of the product points. And if we look, magnesium, magnesium, 2 bromines, 2 bromines, 2 hydroxides, and the 2 waters, so that's 2 hydrogens and 1, 2, 3, 4. I'm sorry, 4 hydrogens, 2 oxygens, and they have that, so they get the balancing point. So they got 2 out of the 4 points on this. So if they knew their solubility rules, they would have gotten another point. And if they knew, which ones are, the 8 strong acids, then they would have gotten that one. Okay, here we have solid magnesium hydroxide. Okay, the fact that it's solid, then they should not have even thought about whether this should break up into ions or not. So they lost their reactant point right there. Okay, their hydrogen's good because at least they knew that was a strong acid. And when they got done here, they do have the right product, okay, and they don't have magnesium, but they shouldn't have magnesium because of the fact that they broke this up. So the fact they broke it up loses their reactant point, but they're going to get both of their product points because for this reaction that's correct, and it's perfectly balanced. So this person got 3 out of 4 points. Now in the second equation, okay, we say cobalt, okay, cobalt nitrate should be cobalt 2+. Okay, they've got the 4 chlorides from the hydrochloric acid, and it turns into the COCl4 with a 2- charge. That's perfectly good. So this person has all the points. Now on this one, then the points, they're getting 2 points for the reactants. Okay, because then there's 1 point for the products. A lot of reactions, there's 1 for the reactants, 2 for the products, but when the readers grade this, they can grade it whatever way they want to. So there's 2 for the reactants, 1 for the product, and it is perfectly balanced. There's 2 plus, here's 4 minuses. So it's nice that they've got all their charges, and be sure you should always check your charges. So they got all 4 points here. Now this person, okay, should have split up their hydrochloric acid. So they've already lost that reactant point. And again, here's nitrate. They didn't split that up either. Okay, so they've lost that reactant point. Even though the chemicals are fine, okay, they didn't split things up. Now, when they're done here, they have a cobalt chloride. Okay, they're only going to get 1 point for the products anyway. Their cobalt chloride, that's a CO2+. They've got a Cl-. They've got a Cl-. That actually is going to count as a coordination complex, and so they're going to get, that point. Okay, so that's fine. And then balancing, everything is balanced, so they actually got 2 out of the 4 points for this answer. But one more time, is back here, it didn't really matter, whether it's true or not, that coordination compound, that you really have 4 chlorides. If they had 3 chlorides, and they wrote it like this, okay, they would have gotten credit for it because they're showing a coordination complex. The fact that it should have been 4, but they did 2 or 3, then they actually got credit for it. Okay, here's somebody, they have a cobalt, and they got chloride, and they have cobalt chloride. Okay, so this person here, again, that same kind of mistake. They're not putting enough ligands on this. In fact, they're actually saying it's a solid, but we ignore that. It doesn't matter that if you write a phase, we just ignore that totally. So this person here is actually going to get 1 point for each of these two products. I'm sorry, each of the two reactants. They are going to get their 1 point for the product, and if they had just stopped and looked at their charges, because this is 0, this is -1, this is +2, they would have realized, oh, I should have put a 2 here, and if they had, then they would have gotten that last point. But as it is, they didn't, so that they have the correct reactants, they have an acceptable product, and it's not balanced. Okay, looking at the third reaction. Okay, copper wire, this person's doing well. Okay, silver nitrate, that looks good. And they show that the copper is getting oxidized and that the silver is getting reduced. So this is one where you get 1 point for the reactants. They get 2 points for the two products. And this is perfectly balanced, so they've gotten all 4 points. Okay, this person, see, again, has forgotten to split this up. So if they knew their solubility rules, even the fact that nitrates are always soluble, now this is going to hurt them twice because they didn't do their reactant and they didn't do one of their products, and they have the wrong charge here. So this person doesn't get the reactant point because they didn't split up the silver nitrate. They're going to lose their product point right here. Well, they also have, okay, this was wrong too. Okay, that is copper metal, shouldn't have had copper ions. So they're in big trouble. This guy here should have been broken up. Okay, that's the wrong charge, so this is all wrong. Now, they still get a balancing point because they have 1 copper, 1 copper, 1 nitrate, 1 nitrate, 1 silver, 1 silver, and they have 2 plus, 2 plus on each side. So even though this equation is not correct, they're going to get their balancing point, so they got 1 point out of this. Okay, this person has copper wire, Ag+, okay, turning into silver, metal, and copper 1+. Now, they get the 2 reactant point. Now they get 1 point for the reactants. Okay, for their silver, they're fine. And the fact that they have this as copper 1+, that actually gets a point because they're showing that they understand that this is oxidation reduction. Okay, this guy is getting reduced, this guy is getting oxidized, and it's balanced, so they got full credit for this equation. Now I'd like to go back really quickly and take 2 examples of the second part of this. So it says a copper wire is dipped into silver nitrate. Okay, so for silver nitrate, describe what would be observed. So as the reaction proceeds, silver metal will be seen plating on the copper metal. Okay, that's exactly right, so they get this point right here. Now notice also, down here, they're using this for their scratch area. Before they write it in here, they went through and wrote copper, silver nitrate, copper nitrate, silver. They're going to, in their head, they're knocking off their spectator ions, and they came up and wrote their equation. So it's just kind of nice to see that you can use this, and as readers, we don't look at anything except for what's in the box and what's on these lines, okay, for your reaction. Unless it's obvious you're kind of spilling over, but to us it's obvious that that's scratch work, we ignore it. Okay, this person here, for this second part, we're saying, describe what is observed. So they say this is a single replacement reaction. Okay, that is true, but you don't observe that. You cannot observe that something is a single replacement reaction. Okay, we went for observations, so we're looking for something that, a color change, we're looking for something building up, something going away. Okay, the wire will begin to look fuzzy. Okay, now this sounds kind of promising because I said if you, when we did this, you do form little silver crystals on there and the wire does get fuzzy, but here's where they lose it, is because as the nitrate builds up on it. Okay, so if they had said as the silver metal forms, okay, then they would have been pretty good, except in their reaction, this is the person that thought that it was silver ions, so they were in big trouble. So this person got 0 points on their products, on their question. So this is how we look at all these reactions. Going back really quickly. Okay, back here, I messed up because I should have stopped and looked at my reaction more carefully, and I left off my magnesium. So unfortunately, I would have only gotten 3 of my 4 points on that first equation. So remember, do net ionic equations. Give yourself about 10 minutes. Okay, see how many points you can get, and hopefully you do pretty well on that predicting reactions.